dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على رسول الله أما بعد السلام عليكم ورحمة الله وبركاته. Welcome to Home. So we talk about the third type of radiation called gamma radiation. Gamma radiation. So when gamma radiation is emitted, so if we have this nucleus, this, for example, this is a radioactive nucleus or this unstable nucleus, when it releases alpha, or when it releases beta, also energy is released in form of electromagnetic wave. So that energy is called gamma. So gamma is energy from the nucleus of an atom. Gamma is energy from the nucleus of an atom. Therefore, gamma rays are electromagnetic waves from the nucleus of an atom. Gamma rays are electromagnetic waves from the nucleus of an atom with high frequency, and also they have a high energy. Gamma rays are not charged. They have no charge. They have not charged particles like alpha. Alpha is a positive, while beta is a negative particles. So gamma rays, they have no charge. They travel about speed of light. They travel 3 times 10 power 8 meter per second. So this is the speed of light. All electromagnetic waves travel same speed. They travel 3 times 8 meter per second. It has no charge. Gamma radiation have a low ionization power. They have a low ionization power, but they have a highest penetrating power. So gamma radiation is stopped by about 25 millimeter of lead. Reduced by 25 millimeter of lead, but they have a high penetrating power. So when gamma is released, gamma usually is released after alpha and beta. Is released after alpha and beta. Gamma rays can be detected by, so these are the detectors of gamma radiation. Gamma can be detected photographic film, cloud chamber, and Geiger-Müller tube. These are detectors of gamma radiation. The source of or atoms that release gamma radiation are iodine 131, cesium 137, radium 226, and technetium 99. So the main laboratory source, so cobalt 60 is used laboratory as a source of gamma radiation. Used as a source of gamma radiation. So gamma emission. When a gamma is released, the net effect of an atom, only energy is released, but the number of protons and also mass number do not change. So when the atoms decay, emitting alpha and beta in form of new atoms produced. When atom releases alpha or beta, new element is produced. But when atom releases gamma radiation, only energy is released, but the atom is still it. So gamma rays only carry energy away from the nucleus and the atom become more stable. For example, we have this is a cobalt. So this cobalt is unstable. When it releases gamma radiation, still it is cobalt, but energy is released. So this cobalt is unstable, but this cobalt is stable. So mass atomic number, that's do not change, but the mass number also it is constant. So number of protons also constant, and number of mass number is also constant. radiation detectors. So radiation detectors are devices that detect the radiation by using properties of radioactive materials. They use the property of radioactive materials. For example, the property of radioactive materials, they ionize the air molecules. They have a, okay. So these detectors, they use the properties of radioactive materials. Nuclear radiation. They use the properties of nuclear radiation. So first one of detector, photographic film. So photographic film or photographic plates used as detector. It detects the radiation alpha, beta, and gamma, 3 types of nuclear radiations. So when a radiation strike the photographic film, it blackens the it causes a blackening photographic film. Therefore, photographic film is used as radioactive detectors. So the amount of blackening depends on the amount of radiation. If the amount of blackening is more, that means more radiation is produced. So photographic films can be used to detect radioactive rays because such plates are blackened by the rays from the radioactive materials. Ionization detector. So the nuclear radiation, when they pass through the air, they ionize the air molecules. So this device uses the properties called ionization properties. So this ionization detector use the properties called ionization. So the ionization property of radiation is used to detect and measure the radiation. By using these properties, is used this device called ionization detector. The 3-1 is spark counter. So this spark counter consists of metal geese, and also this metal geese is negative and also positive. This wire is a positive. So this is a radiation source. So how this device detects the radiation from the radioactive material. So radioactive radiation is invisible, but when this radioactive release, for example, this is a radium. This radium, it releases a radiation. It releases radiation. So this device detects the radiation from the radioactive material. How it detects? Firstly, this is a negative. This metal gauge is a negative, and also this wire is a positive. So when this radiation travels through this metal gauge and also this positive wire, it ionizes the air molecules between them. When the air molecules ionize, the positive charge goes towards the positive positive wire, and the negative charge goes towards the positive wire, while the positive charge goes towards the negative gas. Therefore, this flowing electrons flowing from electrons flowing towards the positive wire. Therefore, current is flowing between the metal gas and also wire. Current is flowing, and also when positive and negative meet, spark is formed. When the spark is formed, when positive and negative meet, sparks can be seen and heard. So firstly, this radiation ionizes the air molecules between the wire and the gas, and current is flowing between them. Therefore, this contains positive charged grid and negatively charged plate. When the radioactive rays pass between the positive charged wire and the negative charged metal plate, ionization occurs, and large current is produced. And pass suddenly between grid and the plate, and also sparks can be seen and heard. The fourth one is a cloud chamber. This is called cloud chamber. this cloud chamber. So first, the components of cloud chamber are, we have a lambi, we have a radiation source, we have radiation source, and also we have inside this chamber there's dry ice. There is dry ice. Dry ice is a freezing carbon dioxide, and also we have felt rings. These are felt rings soaked with alcohol. So this felt ring is soaked with alcohol, and also this is the position of observer. This is the position of observer. So this is the source of radiation. So how this device detects the radiation from the radioactive material? So it detects firstly, we have a felt ring soaked with alcohol. So alcohol is a volatile and it evaporates. Alcohol, it evaporates easily. It evaporates inside this chamber. Alcohol evaporates. When alcohol is evaporated inside this chamber, also we have dry ice. This is dry ice, very cool dry ice at minus 80 degrees Celsius. It is a very low temperature. Therefore, due to this low temperature, this the air inside this chamber becomes super saturated. When it becomes super saturated, this radiation source. This radiation ionize the air molecules inside this chamber. So it ionizes the air molecules alone. It is bad. When it ionizes the air molecules alone, it is bad. Alcohol makes condensation and it forms droplets. This droplet is reflected by the light and can be seen. So this is droplets. So tracks are formed. So these tracks are formed. So this is the path of the radiation. This is the path of radiation. This is the path of radiation. This is path of radiation. This is path of radiation. So this radiation ionizes the air molecules. When it ionizes the air molecules, alcohol forms condensation. When it forms condensation, it forms also water droplets. It forms droplets. So this series droplets can be seen. So therefore, for example, if the radiation is alpha, this strike tracks can be seen in here. This strike track is formed. So these tracks are thick because of they have highest ionization. So alpha has highest ionization power. So these tracks first are thick. These tracks are thick because the alpha have highest ionization power. They are straight line. Because alpha has a greater mass and undeflected by this air. So they are traveling straight line. They are almost the same length. They have the same energy. If the radiation is better, these tracks are formed. So better, this, for example, if the radiation is better, these tracks are formed. So these tracks are twisted, thin, and different in lengths. So tracks are thin because alpha has a less ionization. They are twisted, so alpha has a less mass. So it's different lengths. They are different due to different energy. So they are different energy. So this radiation are different energy. The last one is gamma radiation. So gamma radiation forms scattering. Scattering can be seen inside this chamber. So tracks are short because and thin and also scattered due to alpha has lowest ionization power and has a least mass. Yes, the 5th one is Ionization Detector. The 5th one is scintillator detector. So this detector detects the 3 types of radiation. So this works by radiation. So first it consists of 2 main types. It consists of 2 main types. This part is called scintillating part, and also this part is called photo multiplier. This part is called scintillator part, and also this part is called photo multiplier. So how it detects the radiation? When a radiation strikes this part is called scintillator part. Tiny amount of light is produced. So that tiny amount of light, when it strikes this called the top of photo multiplier tube is called photocathode. Here is called photocathode. When it strikes this photocathode, the small, very small light is converted into photoelectrons. So when this photoelectrons is released, so that photoelectrons is amplified 100 times, 200 times, 300 times, and so on. So voltage multiplier increases the voltage of this tiny this is photoelectrons. So that photoelectrons can be detected and can be measured. So firstly, when a radiation strikes the scintillator bodies, that radiation is converted to very small visible light. The second one, photocathode, converts into photoelectrons. That photoelectrons can be detected and can be measured.